What's going on, everybody? Welcome back to another HackTheBox business CTF video. We just finished up the web category, kind of in a hard challenge for Larablog. And now I think we can take a quick breather. We'll jump over to some super simple reversing challenge. So I have it pulled up here in my web browser. And this Syncopation challenge, just rated with 1-star difficulty, a bit easy, has some good information for us to work with. It says there's more to this binary than meets the eye, and we could simply download this challenge here. It's a downloadable part. Let's get back to my terminal where I still have some of the leftover stuff from this marathon sprint of recording videos. Let's get into the reversing category, syncopation, and let's make a directory for YouTube as we work with things here to showcase to you. So I'll move from the downloads directory, that rev syncopation zip file. We can go ahead and unzip that. And now we have a syncopation program in our current directory that is an ELF 64-bit executable, least significant. Is LSB stand for least significant bit? I'm an idiot, and I've immediately lost all credibility at the first minute of the recording. 64-bit x64 architecture, of course, yada yada yada. We could do the stupid simple, reconnaissance on this sort of thing. Check it out with strings. That'd be dumb and cheesy. It looks like it needs authentication. Based off of that, entering kill switch or invalid authentication, blah, blah, blah. But that's about it. Those are the only worthwhile strings in here. We could, of course, again, make it kind of cheesy in using ltrace or strace. Maybe that would give us a stupid string compare. Hello. Actually, let's do please subscribe because that's classy. Nope. That doesn't give us any worthwhile information, just the puts syntax. We could try to run strace as I'm fumbling all over my keyboard. Again, entering information, nothing really there other than the right calls. So, of course, we have to do legitimate real reverse engineering, sort of, kind of, not a lot. We could open up Ghidra or your disassembler pseudo decompiler of choice. You could use a debugger. You could do any sort of static analysis or dynamic analysis as you would like. And I actually have it already loaded previously, so I'm going to go ahead and just open that up from doing this in real time earlier. So firing up Ghidra, letting this load takes just a bit of time. I might have to amp up the display text here so that's actually visible for you. We can go ahead and analyze it. R2 or Radare2, if some folks used to use that, you'd analyze, you used to enter 5 to 6 A's. We always used to meme about that. We used to joke about it. Let's edit the preferences. Is tool options? Options. Display editor. I hate my life. I'm pretty sure it's... Pause the video while I figure this out. Okay, that's a smidge better. You could right-click in the decompiler section, and it'll bring you to the options display. You could scroll down and simply change the font size there. And doing the same over, actually, in the options, as you notice, okay, that got into the listing tab. Again, the tool options, you could modify the listing display, and that's where you could change the font size. Nice and easy. Let's figure out what we're actually looking at here. The functions, looks like I do see a main function, so we can check that out. And that simply displays here all the variables that would have been used and the kind of input and output stuff that we're working on. Enter kill switch as the string that we saw, a simple read in with getLine, and then verifying authentication as we would want to run it. It will call this checker function. So if we double click on that, it'll bring us into that checker function here in Ghidra, and that looks like it does some loop. I can see a while true in here and a do, so it's going to make some test. This 0x1d looks just to be a hex value if it's less than local 3c, which is an integer that we've used immediately defined as 0, which is odd. So if 0x1d, which we could say is firing that up in Python, just a simple calculator, 0x1d is 29. If it's less than 0, which it's not, this condition would work through. We'd get a uvar that's returned to give us true, and that would get specific offsets here. That would not actually happen because by default that condition will fail. Looks like it will actually work through this loop there when we could modify that local 3C if another condition were met. Though if we were to check if the character pointer at the parameter that we pass in at the index sort of thing because it looks like it's adding that in to iterate over pieces of the parameter that we've passed in. If it's not equal to check indexed at an integer form of our iterator times 5, then it will set this seemingly to hex FFFF and go to code here, which would return the variable. So hex FFFFF is going to give us either 0 or -1. If I'm not thinking off the top of my head, it's not going to return 1 for us anyway, but we need this to return 1 if we were to actually go back and check out. Inside of the main function, we to verify if that checker returns 1, we get the correct authentication, and then it would display theoretically the function, or actually it would exit the program, which looks like a probable like keygen or crack me sort of structure. I can assume that what the input that we need to supply is going to end up being the flag itself. Basically, reading through this, it looks like a simple iterating over verifying that everything that we pass in is equal to every 5th instance or every 5th character inside of this check variable. And thankfully, we can double click on check and have that displayed for us. And looking at that, I see a lot of potential hex and characters that might be worthwhile. This looks like a long entry, and there are 149, but we're only going to check every 5th character. Maybe that's something that is worthwhile. You could go ahead and extract this somehow, some way if you want to. I'm just going to simply copy and paste all this crap. I think that's probably easiest. Does it bring me just about everything? It does. Yeah. So let's copy that whole value, and then let's, I guess, start to tinker, right? We'll create a script just to get me in Sublime Text so we can start to work with this stuff. The kind of banner at the top to reference a few of these for undefined isn't exactly what I want. It looks like it starts with that 4842 EC99 EA54, which already displays down here. So this banner portion is not something that we need. All the others here, we definitely do want these hexadecimal values. So I'm going to hit Control A on my keyboard in Sublime Text to select everything, and I'll hit Control Shift L to create multiple cursors. Now I can kind of move around on every single line within Sublime Text. And I'll use the function home key or the end key to be able to get to the beginning of lines, and I'll move by jumping over words with like Control arrow key or Control Shift arrow key because we're still selecting everything. That I can again Control arrow to the right to grab just the hex value, delete everything else. And also I'll add a 0x in here so it's denoted as hex that Python would represent. And I'll add a comma to denote, okay, this will eventually be part of a big long list. We'll just call that like data and slap it all in here. There we go. Now, if I were to actually work with this, I'll do a user bin environment Python 3, and we could code fold that so we don't have to look at it anymore. We'll do a for I in range 0 length of data stepping by 5. So that way we walk through every 5th character in that data, and we could go ahead and print out that data if we really wanted to. And now, actually, so that should be data index at I, so we can get that specific hex value. Now, all of this is going to be represented in decimal for us as Python works with it, but we could take the character representation of that. That'll bring it into ASCII. That should give us some worthwhile data, but it's going to be segmented all on different lines, so we can join all of that together. Actually, we should realistically turn this into a list comprehension now, because we're getting that value operation on every single instance or element as we work through that list. So we could go ahead and print that out as we join all of the strings that we would retrieve from taking the integer form of every byte in that hex there. Now, if I print this out, we get the flag. So simple challenge, seeing that reversing, quote unquote, is just looking at that loop to say, oh, it's every 5th character. A rather offbeat binary is our flag. And that is that. We can go ahead and submit this, and syncopation is done. I think it took maybe 10 minutes to walk through that, but I hope there was still some adequate learning in there. Not all too bad, just kind of cracking the thing open with Ghidra and looking around. That's all that we really needed to do for this one and kind of making sense of this loop here. I hope that was somewhat useful or enjoyable. I don't know. Wanted to get some coverage on that syncopation category and challenge here, or syncopation challenge in the reversing category. So thanks so much for watching, everybody. Super simple, quick video, taking a good quick breather from the last video working on that hard web challenge. But now we'll move into some other stuff. I'll see. Truthfully, I personally had not solved anything else in the reversing category because I suck at reverse engineering. I think Caleb had been able to take on Sleeper Agent, so I will maybe ask him if he's willing to come on the show for a little bit and showcase that. Sketchy Page was also kind of cool. Again, didn't exactly end up finishing it, but I had some leads on that, and maybe I could showcase that one. But we'll see. We'll keep cruising along, and we'll get to it, etc. Thanks so much for watching, everybody. If you liked this video, please do those YouTube algorithm things, like, comment, subscribe if you'd like to support me. Patreon and PayPal links in the description. Thanks. I love you. Bye.